Hello and welcome. My name is Glenn Pinto. I work within the training department and I'm a principal curriculum developer and senior technical trainer. I am here with Steve Francis, senior software developer, part of the discovery team. Is that right, Steve?
Right.
Steve and I are going to be taking through the world of storage discovery. We'll give you an overview of what it is, a lot of terminology we're going to address today, and then we'll look at some of the architecture and the tables that are associated with storage. Talk about storage credentials, which are crucial to successfully discovering your storage environment, and then we'll end it with a demo. All right, Steve, we're going to talk a little bit about block storage versus file system. This is something that you shed light with me a little while ago. I wasn't really familiar with it. I've seen these terms DAS and SAN and NAS, and I guess people in the storage world kind of know this as second nature, but to someone new, how would you describe each of these three?
Block storage is like a traditional disk. It's storage which you read by sectors. You read chunks of the storage at a time, and there's no organization to it. When a program reads from disk, it'll say, give me sector 400,000, and it gets back this block of data.
Okay.
The file system is what organizes that into something that you can actually use. It gives you directories and file names and.
So C drive, like C drive on your Windows machine, is that considered file system then?
Windows confuses things a little bit because C is both a file system and the disk that it's on, or the disk partition that it's on.
Okay. So it's got both. And what about if I stick like a remote drive into my laptop through like a USB? That's considered block, I would imagine?
Yes, that's block storage, but you can't really use it unless there's a file system on it.
Right, and that's where you do the formatting, I guess.
Right.
Okay.
Exactly, yes.
Yeah. Okay, perfect. And then this thing, SAN, I think this is the one that most of our customers are really looking to discover, enterprise level.
Right, that's when you have a storage array that's got possibly petabytes of storage and thousands of disks in it, and it sits off on the network somewhere, and hosts access that.
And then there's different types of networks between the host and the storage server, right? There's iSCSI, which is your traditional Ethernet network, right. And then there's this thing called Fiber Channel, which is from my understanding, specialized equipment in order to access the storage array from the host, right?
Yes.
Okay, and you just use the term petabyte.
Yes.
What is that? Is that 1,000?
It's 1,000 terabytes.
1,000 terabyte. All right, so now that we know a little bit about file system and block storage, there are lots of terms here that we need to at least have a basic understanding, and later on you'll see it in the demo, so we'll talk about that. We'll see it graphically, and we'll also see it in a demo, and you'll see what's discovered. But the key pieces here are really, there's a storage server. I mean, that's the whole goal of the session, is to understand how to discover that. It's going to be contained with disks, right? Volumes.
Right.
Pools, all these different types of terms, but this is all that extra storage, which you mentioned the term petabytes before. So petabytes, I mean, that's just tons of storage. And it's basically which your host server has access to. So instead of having storage on each host server, you can have a host server have access to a storage server, and multiple hosts can access that. And I assume there's also some rebalancing that can take place with the storage server. So
yes.
One host needs more storage, then it can be easily transferred, right? So
yes,
those are
exactly.
some of the advantages we have there. So there's the two pieces. You have the host that needs to have some place to store information and data, and that happens through a storage server. Now, there's going to be a network that exists between the host server and the storage server, and they come in two flavors. There's your traditional Ethernet network, known as iSCSI, in the storage world, and this basically is made up of your switches and routers and Ethernet cables and all that kind of good stuff. And it's the traditional network that we're familiar with. Is there anything more special about that? Is that
typically
different adapters, right? Is there?
Yeah, so typically, it's going to be high speed, and typically it's not going to be connected to the internet because you don't want some random guy in Minnesota accessing your storage.
That makes sense.
Yeah. So it'll be on a private network. But yes, you nailed it.
And then we have this thing called a fiber channel network. So a fiber channel network, obviously you can see the speeds here are 2, 4, 8, or 16 gigabytes per second. So that's a lot faster because traditional Ethernet is 101,000, from what I've been seeing. And so this is obviously much, much faster. Key things here is that this is specialized equipment. You see something like a fiber channel switch. What are you seeing, Steve, with our customers? Do they tend to run this over traditional Ethernet, or is it more fiber channel that you're seeing out there?
I think it varies a lot. I think customers tend to standardize on one or the other. For the most part, I guess I would say there's more fiber channel
Okay.
than iSCSI.
Yeah, which makes sense. Which makes sense. But I guess the disadvantage is that you're paying for additional equipment. You can't kind of
And
utilize
it's
what's there.
expensive equipment.
And it's
Yes.
expensive, right? Absolutely. So when you hear the term fabric, that's just kind of that's really talking about everything, right? The fabric is your switches, your
Right.
storage, and everything that's considered fabric.
Well,
Or is it
it's the switches and the cabling between it,
the
right? I mean,
cable?
it
Okay,
forms a it's
a
like the
fabric.
fabric in your shirt, right?
Yeah.
It's all the cables that are
Okay.
connecting.
And then we have this thing, the SIM server. I guess this is really one of the more important parts of this whole discovery is that we have an SIM server. You say that it's kind of interchangeably used like SMIS server. You might see it
Right.
basically
Right.
spoken in either way. But this SIM server, from my understanding, and correct me if I'm wrong, is it discovers or it understands basically your storage environment, your storage arrays, your storage server, and all of that. And so when we run discovery from ServiceNow Discovery using our mid server, we're actually discovering the SIM server, which then will expose everything around the storage network.
Right, exactly. Yeah, every vendor uses they all have proprietary interfaces. They often use their own terminology, which can be very confusing.
Mm-hmm.
So SMIS or SIM is just a standardized way that lets us write one storage probe to discover this.
And so something that you had also shed light on me, Steve. You can see you've shed light on me a lot. But yeah, so that is that we actually don't discover the storage server itself,
Not directly,
right?
correct?
We discover the SIM server, which then tells us about the storage server. Correct?
Exactly.
Okay. And also the SIM server, will it know about the host server?
No.
It won't. So how do we discover that? Just
You have to discover the host independently as you discover any other host.
so that's important when we think about setting up discovery, a full, if we want to get everything, our fabric, our storage server, and our host server, we actually have to discover the SIM server and the host server.
Yes.
Correct.
And one limitation that we have is that you have to discover the storage server first. We only create relationships from the host to the storage during host discovery.
Very good to know. And one other thing you mentioned is that the mid server, I talked about connectivity. The mid server needs to have access to the SIM server and the host server, but it doesn't need to have access necessarily to the switches or the storage server because that will be given to us through the
SIM server.
SIM server.
So the SIM server needs access to
the SIM server needs access. And that's really something that's set up on the customer side. That's really
right. Exactly.
Nothing that we would be doing as an implementation team, right? Theoretically. Hopefully not.
Yeah.
And so what we're looking at here, we're not talking about a DAS or a NAS. We're talking about strictly about a little bit more of the architecture of a SAN environment, which could be comprised of all those pieces that we looked at. Now, in this particular graphic, it's important to know that, left and right, left we have the storage server, right we have the host server, and we mentioned that there's all this stuff in between, right? It can be made up of switches, you have Ethernet cables, and it can run over one of two different types of networks, either iSCSI being your traditional Ethernet or fiber channel, which is got all that specialized equipment.
Right.
Right. And so that's why it says, you see where it says fabric, it says fabric or internet, right? Which is fabric's referring to the fiber channel versus or internet, which is iSCSI.
Right. Yes.
Right.
Yeah. They're two completely separate entities that really should show two clouds.
Yeah. But nicely, you can see it all on one slide. But it's important to kind of understand that you wouldn't be running them both in the same network per se.
They're not interconnected.
Yeah,
right?
not interconnected. And so, Steve, how would you describe volume? I see that's a word that's kind of introduced here. What is a volume?
So what the drawing's trying to show. The purple circles represent disks.
Yeah, there we go.
And the storage array doesn't actually just export a disk. It'll take a slice across multiple disks
Okay.
and export that as a volume.
Okay.
So it makes it look like it's a block device, like it's a normal disk,
Mm-hmm.
but it's really sliced across multiple disks.
Okay.
And they do that for redundancy or for speed.
So from the server side, which is on the right-hand side, that's really the host that's looking to store some data on a file system that's on some volume of some disk.
Right.
Is that right?
Well,
Almost.
it's on some volume, but that volume is on multiple disks.
On some disks.
Yeah.
If I added an S, I would have been correct?
Yes.
Okay. That would be good. So, and I like what you put in here. So if you're familiar with ServiceNow and all our different tables that exist in the CMDB, this looks like we extend off CMDB CI hardware. Is that correct? And these are all extended tables off of that. You have storage server, storage volume, and so these are all individual components. But when we actually run the discovery later on, we will be able to see some of these relationships in ServiceNow. All right, last thing we have to cover before we get into the demo are the credentials. So we hopefully have a better understanding visually of what we're trying to discover, some of the different components and pieces like the host server, the storage server, the SIEM server, and then the switches potentially that are either of type Ethernet or fiber channel. But how do we do that without credentials? We actually need credentials. So what we're showing you here are a couple of things. Remember the two key targets that we're looking for to discover is the SIEM server, 1, the host server, 2. And so the host server could be a Windows machine. It could also be Unix, right, Steve?
Right.
Yeah. So
it could actually be ESX also.
Or ESX, right? So it could be a virtual device. Very, very, very true. So it could be any one of those. So we need credentials in order to discover that host server.
Right.
Right. So that's one type of credentials, and that's why you see there, Windows Unix credential for host server. The other piece is the actual SIEM server. Now that SIEM server could be Windows or Unix also, but you said more commonly you see it on Windows, right?
Right.
Right. And now one thing that you shed light on another time is that you don't need the Windows credential to actually discover that SIEM server and the information we need. Is that right?
Right. Yeah. The SIEM server that's running there it's actually a web server, but so it's an application that's running, and we actually connect on a special port.
I see.
But
nothing to do with Windows then, or
no.
Yeah. So basically all we need is the SIEM credential in order to access that.
Right.
Right. So ideally, if we have a host server running Windows and we have a SIEM server running on Unix, we would only need a SIEM credential to discover the SIEM server, and we need the other credential.
The SSH credential.
The SSH credential. There we go. All right. So now and again, that's all we need. We do not need credentials for the storage server, nor do we need credentials for the switches. Right. So those are pieces. We're going to gather that information from what is described to us in the SIEM server.
Yes.
Right. One other key thing here is that those switches could be discovered through traditional discovery, through SNMP potentially.
Yes.
Right. So in that case, those are really discovered as individual CIs, needing the SNMP read-only credential. But you also mentioned, Steve, that they also are discovered through SIEM as well, that might provide additional information around those switches. Is that right?
Right, exactly. Yeah, and this has caused some confusion for some customers because they think that we're going to do all of this discovery through SNMP, and we really don't. We really do all storage discovery through SIEM.
Okay, that's great. All right, you ready to demo?
Sure.
All right, let's do it. We're going to get into a demo now, but first of all, we just want to kind of give you a feeling of what we're going to cover. So first of all, we're going to talk about how to prepare for storage discovery. Really, it's pretty straightforward. We need to have credentials for the host server and for the SIEM server, which basically are going to be a combination of either Windows and SIEM or Unix and SIEM. We need to know what targets, what the target IP addresses are, what the target host names are, only for the host servers we want to discover and the SIEM server that we want to discover.
Right. We need the IP. We don't need the host name is one of the things that we will discover.
And then what we're going to do is we're going to discover the SIEM server or the SMIS server so we can see what that looks like. First, view the results of that storage discovery. So we'll see the type of data that comes back from it. And then we're going to view what type of storage management console do you have? Is it EMC or?
EMC.
An
yes.
EMC console. So after we actually discover everything from our storage server, we're going to kind of compare and contrast what a customer would actually see using a native storage management console, in this case EMC. After we do all of that, we'll look at discovering the host server itself and review its results. All right, so now we are logged into a Helsinki instance, and this Helsinki instance has a couple of schedules that we'll be utilizing, right, Steve?
Right.
You already pre-configure them. As you can see, one is called SIEM servers, and it basically has a couple of targets, is what you said. Right?
Yes.
So 2 different SIEM servers. Now these SIEM servers are running on Windows, is that right?
Yes, I think they both are.
Okay, so they're Windows servers, and they're running in an iSCSI network, from our understanding.
They do both iSCSI and Fiber Channel.
Mm-hmm.
I'm not sure what's currently hooked up.
Okay, right, because it's a test environment, so you can flip them around. Very good. And then we have another schedule here for storage hosts. So these are actually the storage servers we'll be discovering as well.
These are the hosts, right? These are the computers which are using the storage.
Oh, that's right. I see the word storage. You're right. You're right. Yeah. So this is actually, yeah. So the SIM server is going to find out storage.
Right.
Right. And then the host, the storage hosts are really those that are using that storage. Okay. We're going to do it in two parts. We're going to run the SIM server schedule first, and we'll see what we see, and then we're going to run the storage host schedule secondly. Now both of these need access to a mid server, right? So I think we have that already pre-set up correctly. And which mid server here we'll be using? Is it the VM mid?
Yes.
Okay. And we have a status of up and it's validated, so that's good. So again, key takeaway here is that VM mid needs to have access to the host server and also to the SIM server, and not necessarily the storage server. And then in order to discover that SIM server, we need credentials. What type of credential? Do we need Windows or SIM? If I remember correctly, just the SIM credential, right?
Yes.
Yeah, so you have a bunch of different credentials in here. We know one of them works. We're not sure exactly which one at this point, but you do have some of type SIM. So when you click on New, you're presented with this option of types, and the one we'd be looking to configure is the SIM credential. So let's go back then and look at our schedule. And let's run it. So we'll go back into SIM servers, and you can see that it's actually pointed out Helsinki mid. So is that the right mid?
That will work.
That will work.
It's a Unix. It's actually this Mac.
Okay.
So it won't discover the host that the SIM server is running on, but it'll discover the SIM server fine.
Okay. So that's actually a good point. So can you repeat that? So this particular mid is running on Unix.
Right.
And the SIM server is running on Windows.
Right. And we don't support discovery of Windows from Unix mids.
But we still will be able to discover everything that the SIM server provides in terms of the storage.
Right.
Okay, so if you want to know about your SIM server, you really should have a Windows mid. Luckily, so one of these, let's just change that. I think that was put there on purpose as a learning objective as far as I'm concerned. So there's our VM mid. So now that's a Windows mid.
Yes.
So now we can discover storage and also the SIM server in its entirety.
Yes.
Okay, good. So if we look down here at our IP ranges, we have now we have a couple of different IP ranges. So these are two distinct SIM servers running on Windows most likely. Good.
It might be worth pointing out that one of these SIM servers actually manages two storage arrays.
Okay.
This 33.51 manages two NetApp devices that we have.
So let's take a look at when we run Discovery. All right. So now we have our SIM server schedule. Right, it's active. It's pushed out its first probe. I assume that's still a Shazam probe that goes out as the first probe, right? To see
yes.
what ports are open.
Exactly.
Yeah, and if we go under ECCQ, we can see Shazam. Now, which of these protocols are actually being used? If we're not really discovering it through Windows. We're not using the WMI protocol, right?
Right. It's using WebM.
WebM. Okay, so that's this guy over here.
Right.
Okay. So WebM is it must use a different port then.
Typically it uses port 5989.
5989. Okay, so that would be the port that has to be open in order to know that this is potentially a SIM server. Now what happens? I guess that's a good question. If it is a Windows server and port 135 is open, which is the WMI port, then how does it know to run storage discovery versus just a Windows discovery? It's doing both simultaneously.
It'll do both.
It's actually pushing both out.
Yeah.
Okay. So that's good. That's what we talked about before. If it's a Unix server, it won't do that, and a Windows server, it will do that. So let's just see. And here we go. So now we have a lot more stuff running. And if I sort this by created, you can see that we did a WMI classify, and then we've done. And we have a bunch of identity, and then a bunch of exploration probes that have gone out, and then a SIM classify. Okay, so that's because that port, the WebM port, was open.
Right.
So now we're running. So that's a whole different set of probes then that are getting triggered.
Yes, it is a set of probes, right? There are multiple SIM probes that are going to be triggered.
All right, and so while Discovery is running, and Shazam is actually finished, or at least completed, Shazam returned a payload, an XML payload, and what we're looking at right now is the XML payload that we opened up through the ECCQ. And what can we see here, Steve?
Well, you can see that port 5989 is WebM.
Which is right up here.
Right there.
Yep.
And it says that it's open.
Okay.
So this is a WebM server. WebM, I guess it's a little confusing. WebM is the kind of the transport protocol for SIM. So that it's really saying this is a SIM server.
So we know it's open, so that means we ran the appropriate probes.
Right.
All right, let's go take a look now. All right, so this is a nice graphical view of the discovery timeline. You might recall when we built the schedule, we had 2 SIM servers, right, that we were targeting. And one of those SIM servers, you said, had 2 storage.
It manages two
storages, right? And the other one manages just 1. So this first one, you can see that after Shazam run, we did a SIM classify one time, and then a second time down here. The second one.
This is the other.
This is the other. Sorry, yeah. 2 different SIM classifiers because there's 2 distinct SIM servers. And one thing you'll notice that it took a lot shorter to classify that second one than it did the first one for some reason. In addition to that, you can see the SIM identity, right? So that's the identification phase of discovery, where we're really trying to determine, have we seen this this storage server before or not? And you said there were 2, and so here are the 2 different identity probes that ran for 2 distinct servers. And then after that, there were some exploration probes that went out. Looks like there's a DNS probe, there's some file shares, component systems, NASHEAD components. So that's basically what's discovering the rest of the storage array, or I'm sorry, of the SIM server and its description of the storage server. We also classify 2 times, or not 2 times, but 2 distinct classifications of both the Windows servers that the SIM server is installed on.
Right.
So here's the classification of the first one, and here's the classification of the second one. Now, one thing to point out, you might recall that we had that Helsinki MID defined first. If we did, then it wouldn't be able to get past the classification phase because it was a Unix MID, the Helsinki MID. But then we switched it to a Windows MID so we can go through the full classification of that SIM server. So it looks like there are lots of probes here, Stephen. And remember, we talked about how during when we discover the SIM server, we're actually collecting information around the storage server. So which of these probes would we want to look at that's actually performing that action? Is it, I would assume from looking at it, would be the storage server probe, which is right here.
Yes, that's the one that gathers most of the information.
And you were saying that potentially on large storage networks, we have a small storage network. The total time running was only 7 seconds, but you've said that you've seen this run like lots of minutes, right? Like 20.
I've seen it run up to 20 minutes.
And so if we were to look at that that particular probe in this show discovery timeline interface, then that would be a really long line, right?
Right.
Yeah, and kind of distort everything else.
Right.
Okay.
And then the processing of it also takes longer.
Right, of course. So the second part is the sensor script that's analyzing that massive payload that comes back. So Steve, yeah, just to add on to that, I guess if you are running for 20 minutes, does that run into any kind of performance issues that you're familiar with?
It uses a lot of memory on the mid server, and the typical configuration, we used to recommend 512 meg of memory on the mid server, which is completely inadequate. We now recommend 1 gig, which is still often inadequate. For some customers, I've seen it, we've needed up to 8 gig.
What would we have to look for to know whether we're running out? Would the schedule just crash, or would it just take forever, or how would you know whether you need more memory on your mid?
It would run and return no results.
And I'm sure calling support, they would probably have seen that before and be able to easily troubleshoot that scenario, I guess, theoretically, after they come to you, of course. So also part of the status record, Steve, notice under this discovery log, there's a bunch of line items. Over here, these rules have to do with the CI identifiers, whether, to create a record or a CI or update it. But I also noticed these other warnings up here. It looks like those are errors, or are they? Because they're not saying error, they're really saying warning.
So the top 2 are actually happening because of the anomalous times on our SIM server.
We go back to the timeline, yeah.
You can see that this SIM classify took much longer than this SIM classify.
So that's really a warning, really, in our specific environment. It's not something you necessarily will get all the time.
Right. This one, on the other hand, this SIM hosted share, this is a known problem that we have. Some storage arrays don't support this SIM object, and we report it as an error or as a warning when we shouldn't.
All right, it looks like our schedule is now finished, Steve, and we can actually look at the devices related list, and we have 7 records. Looks like they were all created, so they were never found before, so they inserted them into the CMDB. And what we're looking at, I see, obviously, if we start with the easiest things, down at the bottom we see two Windows servers. Those are the two SIM servers that are of type Windows
Right.
that are running the SIM application. The two SIM applications, they're also identified, right? So they're identified as a WebM service. So that's the application themselves, one running on each of the servers, as you can see here, 10.96.33.51 and .81, right, which tie into the two servers that they're installed on. And then up here, these storage servers, I remember you said that one of the SIM servers was managing two storage servers and the other one was managing just one. And so
Right.
that's giving us the three we expected then.
Exactly. Yeah. And then you can actually see and hear what WebM service discovered it.
Right, good. So there's a lot of detail then, and now some of these relationships that we talked about earlier can now be more visualized, which I would imagine would be really valuable to someone who's trying to manage these beasts of storage networks out there.
Yes.
Right. Well, we were just looking at one, and how many volumes do they have? Was it like
13,000
13,000? Was it disks or volumes?
volumes.
Volumes, right? And some of them were petabytes.
Yes.
So just crazy large stuff out there. Right, so I navigated here, Steve, to our storage servers, as you can see under storage. So this is in the Seem2be under storage servers. And these are the three that we discovered most recently with our last schedule. Let's take a look. You wanted to take a look at this EMC one. I believe this is, because you have the management interface, we can actually do some comparing
right.
with.
Yeah, we can look at the native console.
Okay, so this SANLab, it's got the name SANLab, it's manufacturer EMC, and down below we can also see the service, right? This is the service that actually discovered,
Right.
which came from the SIM server, or that is the
That is
SIM
the SIM
server. That is the SIM server. And down below we have a lot of related lists. This one shows us our disks, it looks like, right?
Yes, those are the physical disks which are installed in the storage array.
Okay, and then we have a volumes tab here.
Yeah, those are the volumes, the block devices that have been created from those disks and exported for use by hosts.
Okay. By the host servers, right?
Yes.
Yeah, and then we have fiber channel ports. So these are your Ethernet.
These are fiber channel ports.
These are fiber channel ports.
But again, they're actual physical ports.
They're physical ports that are part of the actual
Yes.
server itself.
Yeah.
Okay, so you're saying we can actually see a lot of this stuff in using this management console, this native management console. We'll be able to see what Discovery sees is what that management console actually sees.
Right.
Okay, so let's go ahead and take a look at that and see how that looks. All right, so on your right-hand side now, Steve, you just logged into this management console. And this management console is in fact interfacing with the storage server directly. Is
Yes.
that right?
Yes.
Okay, and so
This one actually, it depends on the vendor. This management console actually runs on the storage array.
on the storage array, okay, and this is the vendor is EMC in this case.
Yes.
All right, so I would imagine every vendor's interface is going to look completely different.
Radically different.
Yeah. Okay. But the key piece is there that this vendor's EMC, the management console, actually shows under components here. This is under system hardware. It shows 5 disks from what I can see. One was removed, and then the rest are empty. And what we're seeing on the right-hand side is basically ServiceNow showing those 5 disks and the one that's empty as well.
Right.
Right. So if we look here on the ServiceNow side, you can see the disks. One of them is empty, and these are the other 5 that showed that were not empty at all. All right. So now we're going to look at the actual ports, the physical ports that are in the back of the.
Right. The things you plug a cable into. Yes.
Okay. And what we're seeing over here is you can actually click within the storage management console. You can click on different elements or components, and it actually drills in and shows you those actual physical pieces as how they look. That's kind of neat.
Yeah.
But the key thing here is you'll notice there's an SPA and an SPB, and SP stands for, is it
Storage processor.
storage processor? Okay, so that's what controls basically the processing of those ports.
It's the CPU on the storage server. It controls
Okay.
everything on the storage server.
Okay. And what's cool is that you can see over here on the left-hand side, ServiceNow Discovery picked them all up. So it has the SPA and the SPB, and it's displaying everything that would be shown within the management console itself. All right, the last thing we'll look at on our storage server are the pools themselves, or the volumes, I should say. On the right-hand side, you can see what the EMC console is showing us. It's showing us 12 volumes. And on the ServiceNow side, we're also seeing those same 12 volumes. But Steve, I see this word LUNS. What is LUNS? Is that?
It actually stands for logical unit number.
Logical unit number, okay.
Yes. And in the SCSI protocol, that's what identifies a disk
Oh, so it's almost like a sysid in ServiceNow in a way?
in a way.
Yeah. Okay. Very good. And so that we don't really use that terminology within the platform because that's more, is that specific to EMC potentially?
It's not specific to EMC, but yes, there's wide variation in terminology among storage vendors.
Okay.
Vendors will use the same words to mean different things in some cases. So
Okay.
I always try to make sure to call volumes, the thing that we call volumes, I call volumes.
Volumes. Okay.
And we actually follow the naming conventions that SMIS uses.
Okay, so we're not deviating from any standards.
Right.
So now that we've taken a look at what the storage server is discovered and actually what would be seen if you look through an actual storage management console, we're going to go and discover the host as our last thing, our host server. All right, so the last thing we're going to do is we're going to discover some of the storage hosts that are leveraging or using those storage servers that we just ended up discovering. So we're going to use our VM mid, which is a Windows mid, so we'll be able to discover it. And these storage hosts, I believe, are Windows machines as well.
We have a collection. We have some Linux machines, some Windows machines. We actually have an ESX server that's a VMware server.
So we have a whole collection of everything. And here are the targets. So these are all individual host servers. And as we mentioned, we have a wide array of that. So we're going to run discovery on this, and then we'll take a look at what we have. So we just started our discovery of our host servers. And again, Shazam's going out, and we're not going to be using WebM now, right? Because this is not the storage server. This is actually the host server.
Right.
And if they're Windows, we'll be using the WMI port probe, I assume. And if it's Unix, we'll be using SSH.
Right.
You said that some of them are ESX, right?
Yeah, so we discovered ESX through vCenter. So the port probe will actually be a VM app in that case.
Okay, which is the last one listed, right? All right, so looks like our discovery is finished, Steve, and we're looking at the Devices tab. And we mentioned we had 5 targets that are host servers. I'm noticing that we updated one. We created 2, and we couldn't classify the other 2. And if we can't classify it, what does that generally mean?
It generally means that we don't have credentials.
They weren't underneath your keyboard?
No.
I think we got those ones wrong. So yeah, so that was kind of not intentional per se, but yeah, we didn't have the right credentials. We couldn't find them, but that's what you get. We also might not have a right classifier for it, but that's getting into a whole nother discussion. But the key thing is that we're able to discover 3 of these devices, and we're going to take a look at those now. All right, so now that we've finished our discovery of our host servers, we navigated to the Windows module in ServiceNow, and you can see that there's 4. There are, if you look at the created date, we have 2 that were created more recently and 2 that were created from a while back. So those a while back ones are the SIM servers, right, Steve?
Right.
So those are what we discovered when we discovered the SIM servers. Those were also Windows, and now these 2 new ones that showed up more recently, those are actually our host servers, which are also Windows.
Yes.
So let's take a look at one of these and see what we have. So this is the details of the Windows server. If we scroll down to the bottom, you'll see that it has 2 actual storage devices, and I would assume the one that says network and iSCSI is the one that's actually utilizing the storage server.
Right. The other one's DAS. It's an actual disk attached to the computer.
Okay, so that's the local disk then,
Right.
when we think of it in that way. So if I click on that disk itself, this is disk 1, and it's got a size of 100 gigs. It's a pretty good size. And oh, look at this. We can see some upstream relationships that are created. So that is the Windows. It says Windows iSCSI. Is that? Oh, that's the storage volume then.
Yeah, that's the name that we gave the volume on the storage array.
Right, right.
So you can also see here that that there's a file system on top of the disk. Just to reiterate that a file system and a disk are different things.
All right. So E is what is being represented from the host side,
Right.
but
So,
it's using the volume that's showing on the right side. And if I can drill into this volume, I imagine,
yes.
right, and I should be able to see the actual storage volume, and from there I can see the computer, and that is one of the storage servers then that we discovered in our first schedule,
Right.
right, that had a volume that
Right.
and so forth. Okay, so now we actually built the relationship between the host and the actual storage server at this
Yes.
point. All right, we also want to do one last thing. I think that's to look at an ESX server.
So one unique thing that ServiceNow does that other discovery providers don't is we actually allow someone to trace a virtual machine to a storage array, to the actual physical storage that the virtual machine is stored on.
Okay, so that entire path that we saw from the Windows machine all the way to the storage array, we can actually do that even from the ESX server all the way back to the storage array.
Even from a virtual machine
even
running
from the
on an ESX server.
Oh, wow.
Yeah.
And so I remember you mentioned when we were discovering the host servers that one of them was an ESX server, or three of them were ESX servers, right?
Yeah, so ESX gets discovered through vCenter. So there was a single vCenter probe that discovered these three
Got it.
ESX
Okay.
servers. So here's one of the ESX servers. You can see the virtual machines that are running on it.
There's the vCenter that is hosting that ESX.
And then the virtual machines are stored on data stores. A data store is basically like it's like a storage volume, but it's a storage volume that's provided by vCenter.
Okay, so and you can have multiple storage servers kind of making up that data store then.
Right.
Yeah.
So here's one of the data stores. You can see that this HBase, this virtual machine named HBase, is stored on this data store. You can also see that this data store is provided by this disk. You can follow this disk. So here's the storage volume. We follow the link on the storage volume.
And it takes us to NetApp 01, which was what we saw before with our other physical
Right.
host, right?
Right.
So that entire relationship's back. So that's what you're saying is kind of unique within ServiceNow, is that full upstream relationship all the way back to that storage server.
Yes.
Yeah. Okay, that's excellent. Well, Steve, I want to really thank you for your time. I know you're busy working on our next release of a lot of stuff with Discovery, and your time is extremely valuable. And I think this was just great. I think hopefully a lot of people will benefit from this, and I know I did personally. So I thank you very much for that. And
Thank you.
hopefully we'll have a chance to talk again in the future.
Okay.